I am now live. Sorry about my tardiness here, as I'm about 43 minutes late from when I decided that I was originally going to go live. So I do apologize for that for anybody that saw my notification earlier today and was like, oh, that time works for me. I'll go ahead and join him live. So I do apologize for that. For those of you that do not know, because I don't really talk too much about it, but obviously we, finished school, and then I am also a licensed real estate agent in addition to being a full-time teacher and in addition to making YouTube tutorials. So I've been selling real estate as a real estate agent for 8 years now. So it's kind of one of my, gigs that I've been doing for a while now. And obviously with having some 2 kids, I've slowed down, but I still, work a lot with buyers and sellers and helping them find and buy and sell houses. And so I had a little issue with one of my deals that I was working on, and so I had to take care of that. So that's why I'm late, and I apologize for that. And but that's one of the reasons why a lot of people are like, hey, let us know when you're streaming live, like for the day before. And I'm like, I wish I could, but like things come up, and I was like, I couldn't do anything. I had to give all my attention to that certain situation immediately, because that's kind of how real estate is the essence of time is important. So sorry about that again, guys, but I was like, you know what, before I leave, I got to make sure I do this live stream. So I already did schedule it. I am 47 minutes late. I get it. You can let me know about it. I do apologize, but let's go ahead and get on to this because obviously here in the United States, we're going to have Thanksgiving break next week, and there's not going to be a live stream. So, but after that, we're going to pick back up the finishing trigonometry and then wrap up our test. And then before we go away for a winter break. So in this example, we're just going to talk about the unit circle, and we're just going to work on evaluating the unit circle, and that's really about it. So I'm hoping this won't take too long for us to kind of get through this. I will, we did spend all day today in class really talking about the unit circle, where it comes from, why we get these points, as well as our certain our functions for the circle. So I'm just going to kind of do a quick little reference because a lot of this I'm going to be talking kind of quickly on. So I just want to make sure we have the first quadrant of the unit circle. Dang it. I want to make sure we have the first quadrant of the unit circle for your reference in case you do not have a copy of the unit circle or you don't know where it comes from. So we're just going to, and I told my students, for their quiz that they're going to have next week, they need to make sure that they know. I'm going to zoom in because it's hard to write with these points. So they need to know this first quadrant, but they don't need to know the whole rest of the unit circle because I do not believe in just memorizing the points on the unit circle because I don't think it's very valuable or helpful when you're actually trying to evaluate trigonometric functions. So let's kind of get this information out. So again, that is, let's zoom in really close. That's pi over 6. That's going to be pi over 4. And then this last one, that one's going to be, that's pi over 3. And again, where we're getting these points, this is something we discussed in class. So obviously I have a whole bunch of videos on, where these points come from, the explanation of really getting, the special right triangles and all that kind of stuff. So if you are a little bit need a little bit more introduction into the unit circle, just go and check my playlist on that. We have plenty of them. But the quick kind of synopsis here is, this is like the quadrant of a circle that has a radius of 1. And if we take our special right triangles, the 30, 60, 90, and the 45, 45, 90 triangle, and if we place them inside of the unit circle, their hypotenuse is always going to be 1. And based on the side lengths of those special right triangles, that's where these values come into play. And the other thing that we worked on is when we're dealing with we talked about the sine and cosine, or sine, let's just talk about sine. Sine is opposite over hypotenuse. That is when we're given a triangle. And then we talked about a triangle in the x and y axis. So now the representation of sine would be the x value, or the point as far as x over r, where r represents the kind of radius of any circle or the hypotenuse of the triangle. Well, now that we have the unit circle and our hypotenuse is 1, we don't need to put the opposite side over the hypotenuse because the opposite side is 1. So our new trigonometric functions that we're going to work with is just going to be, sine of some angle theta is going to be represented by the y coordinate, cosine of theta is the x coordinate, and tangent of theta is going to be y over x. Okay, now I'm not going to do the reciprocal functions because for this first section, we're just talking about sine, cosine, tangent, and we'll talk about those reciprocal functions later. But again, please remember when you're doing these definitions only apply to points we know that are on the unit circle, meaning the hypotenuse of the triangle is 1, or the, or they're on the point on the unit circle. So, all right, let's go ahead and get into it. I will go ahead and try to answer some questions here. I think we should have some time. So I'll take a break here before I get to multiple choice, answer some questions. So if you guys do have some questions, make sure you guys add them into the chat, and then I'll see what I can do to help you out before I wrap this up. So I'm going to kind of take you guys through my step-by-step process because doing any one of these problems, I want you to be able to get to the point where you can do these in your head, all right? And because that's very important, especially in calculus and for our later chapters in precalculus, to being able to evaluate these angles rather quickly. So at this point, we're going to kind of break it down step by step so you guys can kind of see how to do it without memorizing the unit circle. And then hopefully we'll kind of see some ways that we can kind of like pick it up because I have a lot of examples. I don't need to break down every example. I guess I'd have different angles. So, but either way, let's go ahead and kind of work through this and kind of see what we go through. So I will have to reference this again just so you guys can kind of see where it's at. So the first step that I like to do is when we're given an angle is just to sketch an angle, just to make sure that we know where this angle lies as far as the first quadrant. So I can see pi over 6, is right there, right? And if I wanted to evaluate this, well, I could draw a triangle, right, and then use the unit circle there, but that's not really the point. The easiest thing to do is identify the point where pi over 6 crosses at the unit circle. And fortunately for us, we can see this is our coordinate point. Now, typically, the other thing I look for is talking about the reference angle, but in the first quadrant, the angle is the same as the reference angle. So our main goal is to identify the point on the unit circle that our angle that the angle would create or cross at that point. So the point that pi over 6 crosses at the unit circle is going to be square root of 3 over 2, comma 1/2. All right? So now, remember, that's your x-coordinate, that's your y-coordinate. So if I wanted to evaluate the sine of pi over 6, now I'm going to write this out first, right, because that's really what you're doing. But for the sake of time, for the future problems, I'm just going to use theta because all of them are all theta. So the sine of pi over 6 just represents the y-coordinate, which in this case is 1/2. The cosine of pi over 6 is just representative of the x-coordinate of the point on the unit circle, which is square root of 3 over 2. And then the tangent, I'm going to do this once so you guys can see the work, but what you guys will see is this is going to repeat itself, so we're not going to have to do this every single time. The tangent of pi over 6 is, again, remember the y over the x, right? The y over the x. So I'm going to take 1/2 and divide it by the square root of 3 over 2. That's kind of small. Let's zoom that in one more time. So that's 1/2 divided by square root of 3 over 2. And then what we talked about in our previous lesson as far as like rational expressions, when I have a fraction divided by a fraction, to get rid of the fraction in the denominator, I would just multiply by the reciprocal. So I'll multiply by 2 radical 2 on the top and the bottom. And what you guys will see here is that obviously multiplies to 1. These 2's divide to 1. And we're just left with 1 over, why am I multiplying by the square root of 2? Come on, guys, you're like my students. Everybody asking, get these done. That's square root of 3, right? That's the reciprocal. The reciprocal here is square root of 3. So that's a 2, and that's a square root of 3. Okay, so anyways, that still goes to 1. The 2's will divide out to 1. I'm left with 1 over the square root of 3. And then my 1 point showing you how to rationalize the denominator, multiply by the square root of 3 on the top and bottom. And therefore, you guys will get square root of 3 over 3. So from now on, if you guys need help with, like when I say rationalize the denominator, you can always refer back to this one. Or if you don't understand how I'm getting, going from here to here, you can refer back to this problem. Because I don't want to do this work for every single one. It'll take me forever to do this homework. And that's the point of the unit circle, or that's the point of evaluating based on the unit circle, is to start identifying, some of these patterns and tricks. So the main important thing here is also that let's talk about theta prime is the same one in that first quadrant. That's important. And really, this quadrant here is really the representation of all our reference angles. So we'll talk about that here in the next one, as this one's good. So the next one, we have theta equals 3 pi over 4. So again, step number 1, let's just graph 3 pi over 4. I know that halfway around a circle is 4 pi over 4. So if I need to go to 3 of them, basically cover 3 of them, then my angle is going to be right there. So that's my theta. Now what we want to do though is understand our reference angle. And again, remember the reference angle is the acute angle between the terminal side and the x-axis. So that is theta prime. And what's important about theta prime is obviously it's positive and it's acute. So if theta prime's here, that's the same as what it would be in the first quadrant. They're the exact same point. You guys can see that these points are going to have the exact same values. The only difference is they are a reflection about the y-axis. So the reason why this is important, and now this one, we didn't have to worry about this one because the reference angle and the angle were the same. They're in the same first quadrant. But in this case, what we want to do is identify the point of the reference angle. So I can say that theta prime is equal to pi over 4, right? Because if I went 3 pi over 4 and 4 pi over 4 is halfway around the circle, then I just need this little chunk pi over 4. So let's find the point of theta prime for pi over 4. So I go back up to my circle and say pi over 4. That coordinate point is square root of 2 over 2 over 2. And then square root of 2 over 2 over 2. Well, now that I know this point, but again, that's not the point we're trying to find. We're trying to find the point of the unit circle for our angle theta. So for my angle theta, it's going to be the same coordinate point, the same values, but now since it's in the second quadrant, I know that my x-coordinate is going to be negative. Oops, not for theta prime, just for theta. So the point of my angle theta, where it crosses, is going to be it's negative square root of 2. Come on. Negative square root of 2 over 2, comma, square root of 2 over 2. Okay? So now, here we use this point in the first quadrant. Now we're going to use this point because it's in the second quadrant. That's where my terminal angle lies. So again, the same kind of thing is going to apply here. I'm going to go ahead and do the sine. Now again, instead of writing sine of 3 pi over 4, I am just going to replace that with theta just because it's going to make my work go a little bit quicker. So I have sine of theta is going to be the y-coordinate, which is square root of 2 over 2. Let's see, the cosine of theta is going to be the x-coordinate, which is going to be negative square root of 2 over 2. And the tangent, I'll write it out once because so you can see it, but we don't really need to do that after that. So that's going to be square root of 2 over 2, the y over the x, over negative square root of 2 over 2. But what you notice is, even though these are fractions with radicals, they're exactly the same. So anything divided by itself is going to be 1. And obviously 1 is positive, 1 is negative, so that's going to simplify down to a negative 1. All right, next one, 5 pi over 3. So let's go ahead and sketch that. Well, we know that half of a circle, guys, is 3 pi over 3. So again, it's pi, right? All the way around a circle would then be 6 pi over 3. Well, I need to get to 5/3, right? So what I'm going to do in this case is I'll break the top. You can see why that's 3/3, and then this would be 3/3 down here. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So I need to get to all the way over here. So there is my angle. So that is my angle theta. Let's put theta right there. All right. Now, again, what we want to do is identify this reference angle. The reference angle is the acute angle between the terminal side and x-axis. And what we see is, obviously, if I traveled 5 pi over 3, all the way around the circle is 6 pi over 3, that means my reference angle is going to be pi over 3. So I can look at my reference angle in terms of the first quadrant to find the coordinate point. So I go back up to my unit circle. I say, all right, the coordinate point for my reference angle pi over 3 is 1/2 comma square root of 3 over 2. So all right, 1/2 comma square root of 3 over 2. But again, that's for my reference angle. I want to find the point down here, right? And you can see it's the same point. It's just a reflection about the x-axis. So what that means is my point is just going to be the negative value of it. So therefore, that's going to be a positive 1/2, but it's a negative square root of 3 over 2. All right, so now I can evaluate the sine, cosine, tangent. So let's do sine of theta, which in this case represents 5 pi over 3. So that's the y-coordinate, so that's negative 3 over 2. The cosine of theta is the x-coordinate, which is a positive 1/2. And the tangent of theta, did we do this one yet? Sine over cosine? No, we didn't do this one yet. So now let's go and do this ratio. Again, I'll break this one up so you guys can see it. But then I'm not going to do it again because we don't need to. So let's take negative square root of 3 over 2 divided by positive 1/2. Again, just like I did before, guys, multiply by the reciprocal to get rid of it. And that goes to 1. The 2's divide out, and you're just going to be left with negative square root of 3. So that would be my answer for that. Okay, so we've built these up, and now for any other time that we see these show up, we'll be able to just use those same answers, and you'll see when that comes up. Now we got to graph an angle that is negative, so nothing wrong with that. We just remember that for all of our positive angles, we are always going counterclockwise. So when we have a negative angle, now we're going to be going clockwise. So we're going to be going in this direction. So again, halfway around a circle in terms of 6 is 6 pi over 6. And it looks like we are just pi over 6 short, right? So, I mean, if you want to break these up into 6 parts, you're more than welcome to. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. And then again, we just want to travel 5 pi over 6, right? So there is our angle, theta. Again, though, we are going to be most interested in identifying this reference angle. Oh, did I not write the reference angle here before? No, I didn't. So let's write that in there real quick. So theta prime is equal to pi over 3. All right, so our reference angle in this case is going to be pi over 6. That's how far we are away from the x-axis, right? Because if you take pi over 6 plus 5 pi over 6, you'd get 6 pi over 6. So let's go and find the coordinate point here for our reference angle in the first quadrant. So then we go up here, and this will be the last one I'll reference here since you guys have seen this enough. And you can see the reference angle has the coordinate point square root of 3 over 2, comma 1/2. So that coordinate point is square root of 3 over 2, comma 1/2. All right, but again, if you guys notice this is a really bad representation. That's a kind of a big angle there. What you guys will see is this is basically a direct reflection about the origin. So it's the same coordinate point, right? Here's your coordinate point on the unit circle in the first quadrant. Here's the point here in the third quadrant. So what we know is it's just a reflection about the x and the y. So basically our point is the exact same. The only difference is it's in the third quadrant, meaning that both coordinates are going to be negative. So our coordinate point is negative square root of 3 over 2, comma negative 1/2. So now to evaluate the sine, cosine, tangent, sine of theta, which represents negative 5 pi over 6, is going to be negative 1/2. Cosine of theta is going to be negative square root of 3 over 2. And the tangent of theta is going to be the y over the x, which we didn't do here, but we did do the y over x over here, and you can see that simplifies to square root of 3 over 3. So I'm just going to keep it the same answer. However, notice that it is a negative over negative, so it will be positive. So that'd be a square root of 3 over 3. Was that the same angle? What was that? Oh, yeah, it's pi over 6, so yeah, it's going to be the same. So the tangent will be the same, but the sine, you notice that sine and cosine are both negative because it's in the third quadrant, okay? So I'm not going to reference the unit circle. If you guys need it, again, these are our definitions for points that are on the unit circle as far as evaluating the sine, cosine, tangent. And then here's the unit circle that I'm using to evaluate all these points. So I'm going to still follow the same process, but I'm not going to keep on referencing these back, just so we can kind of move a little bit smoother throughout the rest of the homework. All right, so negative pi over 4. I am going to still do a rough sketch, though, because I still like doing that. So negative pi over 4, that angle is going to be right there. Okay, so my reference angle, which would be, so here's my theta for my reference angle, is equal to pi over 4. The coordinate at pi over 4 is going to be square root of 2 over 2, comma square root of 2 over 2. I notice that negative pi over 4, though, is in the third quadrant. So therefore, this coordinate point is going to be the exact same, but again, my y coordinate is going to be negative. Okay, so now when I want to do my sine and cosine, again, I'll just use theta instead of negative pi over 4. So I'll say sine of theta is my y coordinate, which is negative square root of 2 over 2. Cosine of theta is the x coordinate, which is square root of 2 over 2. And the tangent, which we already did, so we're not going to redo this, right? They're exactly the same over each other, so that equals negative 1. And there you go. Next one, negative 2 pi over 3. So let's sketch that angle. That's going to be 2/3 here, down here. There's that angle. So we want to figure out what that point is. So we'll use the, let's use the reference angle here. Oh, let's put, here's our angle theta. So our reference angle is right there. So the reference angle here is going to be the distance from the terminal side to the x-axis, which in this case is going to be pi over 3. And the coordinate point at pi over 3 in the first quadrant is going to be 1/2 comma square root of 3 over 2. But what I notice about this point is that it's in the third quadrant. So therefore, both coordinates are going to be negative. So now when I evaluate my sine and cosine, sine of theta equals negative square root of 3 over 2. The cosine of theta equals negative 1/2. And the tangent of theta is going to be y over the x, right? Well, we've already done this one. We did this one over here, y over x, same thing. Now this one was negative, one was positive. Here I have two negatives, so it's going to turn to a positive, but my answer is just going to be the square root of 3. So the nice thing about this is once you start doing this, like that's why I'm kind of doing so many repetitions for my students, is they can start like copying back the answers. Like, I mean, you're starting seeing these patterns. So that's what's kind of, helpful with this. And then what are these, the last ones? Okay. So now this next one is one that is larger than 2 pi. So we want to kind of look at this as far as seeing a way that we can, kind of do this one. Now this one, I know that, here is 4 pi. Again, we're going in the negative direction. So that's 4 pi over 4. And then from here to here would be 8 pi over 4. So to get to negative 9 pi over 4, I need to do one more pi over 4 over. So there's where be my angle and the point on the unit circle. So I go all the way around the circle and then an extra pi over 4. Another way you can do this is rewrite this in terms of a period. So we know going all the way around doing a full revolution in the negative direction would be negative 8 pi over 4. And then to get to negative 9 pi, I would just need to add a negative pi over 4. Now, fortunately for us, we already did this problem, didn't we? I thought we did. No, we didn't. Yeah, we did. We did negative pi over 4 here. So I can just use those answers because I didn't mean to actually do that. So that's cool. So sine of theta is negative square root of 2 over 2. Cosine of theta is going to be positive square root of 2 over 2. And the tangent of theta is equal to negative 1. And again, this is just the exact same answer as E. So once we use period as an aid, we see that just is a revolution around the circle. We need to go an extra negative pi over 4. So it's really the same values as that angle. All right, let's go and do 10 pi over 3. So if you think about this one, again, in terms of a period, I think it can help you out. Because if you think about a revolution in terms of thirds, that would be 6 pi over 3. And then what would I need to add to 6 pi over 3? Well, 4 pi over 3. So this is just an extra revolution. Don't worry about it, right? That's literally just going around the circle. Let's just graph it. That's literally just going around the circle. That's 6 pi over 3. Now we still need to go 4 pi over 3, which is going to take us all the way down here. Okay, so this extra revolution, we can just forget about it. Just evaluate it and then just get rid of it. Now, we didn't do a 4 pi over 3, did we? I mean, I'm kind of liking this using our old answers. 5 over 3. No, we didn't do a 4 pi over 3. Okay, so let's go and investigate this one now. And so for 4 pi over 3, that basically means here's 3 pi over 3. We went to 4 pi over 3. So our reference angle, which is right there, is going to equal pi over 3. And again, the coordinate point for the reference angle would be 1/2 comma square root of 3 over 2. So therefore, if we're looking for the point, though, that's in the third quadrant, that's going to be both negative. So that'd be a negative 1/2 comma negative square root of 3 over 2. And therefore, we can just say that the sine of theta, which represents 10 pi over 3, is equal to negative square root of 3 over 2. The cosine of theta would equal negative 1/2. And the tangent of theta, if you can find my answer, it's somewhere here, but I already know the answer is negative square root of 3. Because I'm starting to do things, I'm starting to follow these patterns, right? And that's where I want you guys to get to. All right, 4 more to go. Whew, kind of it. So we have negative 15 pi over 6. Again, let's use that period as an aid. I think it's really helpful. So a period for 6 in terms of, or revolution, it would be equal to a negative 12 pi over 6. And what would I need to add to negative 12 pi to get 15? Well, that'd be a negative 3 pi over 6, which is really simplifies to negative pi halves. Okay? So really what I'm just being asked to graph is negative pi halves. And remember, guys, halfway around a circle is pi. So if I would need to do half of that, that would look like right there, from there to there, which is really 90 degrees. But we don't write it as 1/2 pi. We write it as pi halves. And again, these are the measurements, but we're going in this negative direction, right? Now, the interesting thing here is we don't have a reference angle because reference angles have to be acute. So the nice thing that we can do now is we can actually, I'll reference the unit circle one more time. But what we can do is actually reference our understanding of the unit circle. Like this is just that first quadrant of the circle, right? Remember the radius is 1. And all of these come from our right triangles. But remember the definition of our trigonometric functions based on points on the unit circle is just the coordinates of a point on the unit circle. So if we're looking for this, like if you see here, this graph, there's no triangle here for positive 90 degrees. But you can see that the unit circle has a point at 0, 1 for an angle 90 degrees. So if I was to look for an angle for negative 90 degrees, it would be this exact same point, but just down, down below here, and that'd be the corner point 0, negative 1. So that's where I'm going to get this point down here, 0, negative 1. So now I have my x and y coordinate, so I can just say sine of theta is equal to negative 1, cosine of theta is equal to 0, and then the tangent is the y over the x, which is equal to negative 1 over 0, which we don't need to write here because we know we can't divide by 0, so that's going to be undefined, okay? And I just use abbreviation UND for that. The next one is 3 pi halves, which if we kind of think about that, like here's 1/2, here's 2 halves, here's 3 halves. So I did a really poor job on picking my homework problems today because that's the exact same point. Right? I mean, it's at 0, negative 1. Good job, Mr. McLogan. Jeez. I guess I was tired or lazy on this one because it's the same answers. But either way, whatever. You get some practice, and maybe that helped some students out seeing, oh, it is the same answer. It's just completely, represented differently, right? But you can see that they both give you the same point on the unit circle, so therefore the values of your trigonometric functions would be the same. All right, well, this one's not going to be the same for anyone. This one's negative 3 pi. So let's go and graph that. So again, we're going negative direction. So from here to here is pi, 2 pi, 3 pi. So what point is that on the unit circle? Well, again, let's kind of like pretend to draw the unit circle here. If this is 0, 1, then this is 1, 0. So if I'm at this point right here, I can see that's going to be negative 1, 0, right? So that's where my angle is going to lie, and now I can just use those x and y coordinates. So I'll do sine of theta, which represents negative 3 pi in this case, is 0. Cosine of theta is negative 1. And the tangent of theta is going to be the y over the x, so that'd be 0 over negative 1, which is just equal to 0. Whew. All right, last one. at least until we get to the reciprocal identities. And then we have a couple multiple choice, and then we'll be finished. And I think, yeah, we'll be doing pretty good. I wanted to go at least till 4:30 today, so hopefully I can answer maybe some questions for you guys that have coming up. So last one here, we have 5 pi halves. Again, guys, if you think about this in terms of halves, so this would be pi in terms of pi halves, that'd be 2 pi halves. All the way around the circle would be 4 pi halves, which is the same thing as 2 pi. And I just need to go to 5 pi halves, so I'm just going to go an extra pi half, right? And we talked about that coordinate point on the circle is 0, 1. And so now let's just go and do the same thing. So these are rather simple when they're on the axes, as long as you kind of understand them and know how to graph them. And I think that's really kind of the important distinction for a lot of students is being able to get to the point of graphing them. And a lot of the times the problems where students get wrong is just they don't have the initial points from the first quadrant memorized, y over 0, so that's undefined, and they just get the quadrants mixed up, so they get the wrong negative symbol. So that's usually what happens. All right, so now let's go ahead and evaluate the secant, cosecant, and cotangent of the following angles. Now, it is important to kind of talk about, what I gave my students the notes. I gave them the reciprocal identities. So cosecant of theta is equal to 1 over y. The secant of theta is 1 over x. And the cotangent of theta is x over y. But I wanted to, when you're doing these mathematically, what I found was this isn't usually the easiest way to kind of think of them. Because if I think of sine, if you remember the good old days of opposite over hypotenuse, right? It wasn't that long ago. Well, then the cosecant of theta was just the reciprocal hypotenuse over opposite. So even though this isn't you could think about this as a reciprocal, or really you could think about this as y over 1, and you can think about cosecant as 1 over y. Just reciprocate it. So rather than putting it over 1 and trying to simplify it, if you can think about this as a ratio and the cosecant is the reciprocal, it's going to make your math easier, at least in my opinion. I'll do both of them so you guys can kind of see how that works. Well, I guess we'll only see. Yeah, I'll do it both for the pi over 3, so you can kind of see what I mean by that. But the main important thing, we still want to find the points. So at pi equals 0, well, pi equals 0, that graph hasn't moved, right? So that's the coordinate point 1, 0. And again, so if we think about this, if we look at the secant, that is going to be 1 over x. So 1 over 1 is just equal to 1. If we look at the cosecant of theta, that would be 1 over y, so that's going to be undefined. And the cotangent of theta is going to be x over y, which again is going to be undefined. So again, in this case, it's actually helpful to see using the reciprocals as 1 over. It's helpful in that regard. So for this example, I would say it's helpful. In this next one, if I was going to scratch negative 1/2, that's the point down here. So that's the quarter point 0, negative 1. And again, let's just use our reciprocal identities here. So the secant of theta is 1 over x, so that's going to be 1 over 0, which is, again, undefined. The cosecant of theta is going to be 1 over y, so that's 1 over negative 1, which is equal to negative 1. And the cotangent of theta is the x over the y, which is 0 over negative 1, which is now equal to 0. Secant, yeah, it's 1. Cool. Y. Cool. All right. Last one here is the pi over 3. Hopefully you guys just know, pi over 3, it's in the first quadrant, so therefore I don't need to worry about reflecting it all. That coordinate point is 1/2, square root of 3 over 2. Now here, I don't like using the reciprocal, the 1 over idea, because I'll do it for secant, but then I'm not going to do it for the cosecant. So watch, if you do secant of theta, and you say, well, that's 1 over 1/2. Well, guess what what you have to do? Now you have to multiply by the reciprocal. And fortunately for this one, it's not too bad. You get 2. But do you really want to do square root of 3 over 2, multiply by the reciprocal, and then simplify? No, you don't want to do that, right? So the easiest thing to do here is just to reciprocate it, right? Just like I said, if it's y over 1, just rewrite it as 1 over y. Or I'm sorry, if it's like opposite over hypotenuse, just rewrite it as hypotenuse over opposite. So the easiest thing, in my opinion, is just to rewrite it as its reciprocal. Then you can just rationalize the denominator and get 2 radical 3 over 3. And the last one here, I have cotangent of theta. And that's going to be my x over my y. So I have 1/2 over square root of 3 over 2. And what you guys can see in this case is we've already done a problem like this, and that's going to equal square root of 3 over 3. I think, right? Yes. Okay. That would be that case right there. All right, guys. So I'm going to just finish up or wrap up these couple. I think I have 4 multiple choice questions. So I'll go ahead and get to those in just a second. Just want to kind of check in. For those of you that have joined in the stream, I appreciate it. And again, I'm sorry for those of you that might have been caring. How do I get my teacher fired? You can't teach. Hey, Couch. Well, you know, obviously I would not recommend anything. But again, like the same thing is, I don't think, I think that's kind of an interesting point you brought up. I think in this time where it's awesome that I think that I have the opportunity to, live stream and make videos that you guys can learn from. And I think that really is the future of a lot of education where, you guys don't need to be bound to what state you live in, what country you live in, what your economic situation is by any means. Like, I think the education is, available to all. And I think that's a really, really cool thing that you guys have the opportunity for, that previous generations, even including myself, didn't have opportunity. Like, you got your teacher and there was really nothing else you could do. So, I think this opportunity of you guys being able to learn online and, get access to teachers like myself that are, willing to put that information out there, I think is really, really powerful. So, my advice to you is, we've all had teachers that either were bad teachers or teachers that we just didn't connect with. But don't hold that back. You can learn anything you want to learn. All the resources are out there for you. So, take advantage of what you can. And because there's no limits to what you can do, really do. But I totally get it, man. I feel for you. I've been there very much. So, hey, Happy Cord, happy to have you in. Tom, this is me reviewing, Tom111, this is me reviewing my homework for my students and live streaming it live for all of you guys out there. Jeremiah Thompson says, should I be learning this in 9th grade? Depends what you're taking in 9th grade. Typically in trigonometry, most of my students are either sophomores or juniors and seniors. So I really I do have a mix. I didn't take precalculus until I was a senior in high school. And then obviously I had to take it again because I didn't really learn enough. So I had to take it again in college. So basically this is something that can cover college precalculus, college trigonometry, or high school trigonometry class. I've never taught a 9th grader in precalculus, but that doesn't mean obviously some people, will get to that point or even they're already past that point. So, but I would say you want to make sure that you've at least in Algebra 2 before you get into the trig. It's kind of very helpful. Cream says it's going very good. As I mentioned, guys, I was late to my stream because I had some issues with my real estate. And actually, my phone has been blown up. I've missed up a whole bunch of phone calls. So I'm kind of interested to see once I get off this live stream what has actually transpired since I've been talking to you guys. But I don't want to answer the phone when doing it on the live stream. So I love Doris says you look the same 6 years ago. Well, thank you very much. I appreciate that. I don't really know. I'm trying to still keep a workout, keep myself young, and obviously my students and my children are definitely keeping me busy. So I appreciate that. I don't think this is a regular stream because he doesn't read the comments. Well, Life with M2, I do read the comments, but if you've watched my streams in the past, which I'm not sure you have, I always try to let you guys know that I do a live stream of this content first, and just for the sake of time, I try to get through it all. And then what I do is I take a break before the multiple choice, have a little fun, read some comments like yours. And then what I'll do is I'll finish up the multiple choice because some people want to do the multiple choice. I don't know. Maybe. Do you guys want to do the multiple choice? I just kind of figured like that would be a good kind of break. And then obviously people that don't care about me listening to talk, when they watch the replay, they can just kind of skip to the end. So, Ronub sub, I live in Florida, by the way. And Esmeralda says, do you teach AP Calc? This year I do not, but the last 2 years I did. So I do have a whole bunch of calculus videos for you as far as on that. So hopefully those videos can help you guys out. And Life with M2, can I ask a question? Yes, please feel free to ask a question. I'll be happy to help you out. Can you do a video about applying systems? Well, it's kind of hard for me to create a problem with systems of equations and word problems because that's not something that's just like very easy to come up with. So if you do have a problem and you can let me know about that, I'll be more than happy to do it. I don't have too much more time left on my stream, but that's, if you can provide something, I can try to do my best to at least set it up for you, and then I can help you out. But obviously, just creating a problem or going over it now is not going to be the time, because I try to keep my live streams here between, around between 30 and 40 minutes, and I think right now we're kind of getting close to 40 minutes. I think, I don't know, don't really check too much, but. How much you say me? Well, I'm happy to help you with your thing. So which state? I live in Florida, Jacksonville, Florida. So, but I'm born and raised in Michigan. So from the Midwest, and then moved down to Florida for a teaching job, and that's where I've kind of stayed. So, all right, let's go ahead and wrap this up. And then if there's any other questions, or if you're able to get that systems of equation question maybe, or something that you can help me out with, I'll see what I can do for you. All right, so without a calculator, what is the exact value of cotangent of 4 pi over 3? So if I was going to try to do this as quickly as possible, I would think about, all right, 4 pi over 3 is down here. That's the angle. The reference angle then is pi over 3. That means the coordinate point is 1/2, comma, square root of 3 over 2. Cotangent is x over y. So that would be 1/2 over square root of 3 over 2. I remember that simplifies to square root of 3 over 3. And it's in the third quadrant, so that would be negative and a negative, which would make that a positive. So B would be my answer. Tangent of 45 degrees minus tangent of sine of 60. Sorry. So remember, sine of 60 is the same thing as pi over 3. Tangent of 45 degrees is the same as pi over 4. So those quick kind of conversions are helpful to make sure you have, rather than having to rely on the conversion ratio. Let's think about this. These are both in the first quadrant, so that's good. And so these points that we're using is square root of 2 over 2, comma, square root of 2 over 2. That's the coordinate point for pi over 4. And for pi over 3, it's 1/2, comma, square root of 3 over 2. So the tangent of this is 1, and the sine of this angle is going to be square root of 3 over 2. So if I was going to subtract these, what I would do is I'd rewrite 1 as 2 over 2 minus square root of 3 over 2. And then I can rewrite them as a common denominator. And 2 minus square root of 3 over 2, which is, I'm getting as C. Find cosine of 7 pi over 6 exactly. So 7 pi over 6 again is in the third quadrant. That's my theta. My theta prime is pi over 6. And the coordinate point on the unit circle for pi over 6 is going to be square root of 3 over 2, comma, 1/2. This is in the third quadrant, though, so that's going to be a negative square root of 3 over 2, comma, negative 1/2. So therefore, my answer would be B. And without a calculator, what is the exact value of cosine of 120 degrees? So again, we don't need to really convert 120 degrees. I need to know where 120 degrees is, roughly there. And so that's 120 degrees. I need to know the reference angle. So if halfway around the circle is 180 and you just traveled 120, well, then that means that's going to be 60 degrees, right? So we can say the reference angle is 60 degrees, and I should know that that in radian form is pi over 3. So again, we're in the second quadrant, so we know that our point over here is going to be negative, or the x value, right? Because cosine is representing the x value, so that's going to be a negative. But the coordinate point for pi over 3 is 1/2, comma, square root of 3 over 2. Since it's in the x quadrant, it's going to be negative, so therefore that's why we get negative 1/2. And there we go. Awesome. We're all done with the homework. Hopefully that helped you out. Just a kind of a quick little review of the process that we did. Reciprocal identities, you can write them as 1 over x, 1 over y, or x over y. Or when you're dealing with our initial fractions, just use the reciprocal. It's the easiest way. Find, your point and then just reciprocate it. As far as for these angles, the steps you want to follow is sketch the angle, identify the reference angle, identify the point of the reference angle in the first quadrant, and then apply the positive and the negative signs, or apply the negative signs where applicable, of which quadrant the angle lies in. And then once you have that angle lies in, or once you know the quadrant that the angle falls in or lies, then you can just go and use these definitions for your sine, cosine, and tangent based on these coordinate points. So there goes, ladies and gentlemen. Yep, Catering, Michigan. Absolutely. And I'm in 7th grade and he helped me out. Well, awesome, Jay. Happy to help you out, man. This is, I haven't taught, I actually, what I did my student teaching was in 7th grade, but it's been a while. And one of the things that I'm looking actually into is actually kind of going back. I'd like to, I've spent so much time in like the algebra 1 through calculus section. I would really like to start exploring like post-secondary math as well as like elementary math. I think that'd be like kind of cool to like go in both direction, because one thing I definitely do miss is the mathematics past high school. When I was in undergraduate and taking those classes, I really loved like learning about all the math. So I'd like to kind of continue that. But then in the same respect, I like to go back and like discover like these foundation of foundational ideas in mathematics that, from what I've seen as a math teacher in high school, that myself didn't grasp, or that I see students as well, didn't fully grasp, and really just kind of seeing a way that I might be able to teach, and not saying I could do them better or whatever else, but, getting an opportunity to kind of teach some of those foundational math concepts, just some ideas. I don't know, trying to get some new videos, obviously 11,000 videos for high school mathematics. It doesn't even get close to covering everything, but it's covered a lot, right? I mean, this isn't the first time I've covered these. I probably have like 100 videos on trigonometric identities or evaluating trigonometric functions. So, looking for some different things to kind of branch off. Obviously, I think I'll be teaching this stuff for a while, but, we'll kind of see. So, all right, guys. Well, I am going to get off. I appreciate you guys joining the stream here on Friday. Again, for those of you in the United States or anywhere in the world that is celebrating the United States Thanksgiving, enjoy your time off. And then after a week after that, after next week, we will get back into the live streams. We'll be get back into graphing trigonometric functions, and then we'll talk about inverses of trigonometric functions. And so we'll have some live streams and some homework to cover with you guys on that. So otherwise, I hope you guys enjoy. Thanks again for joining the stream, and I will talk to you guys next time. 47 minutes.